today we're going to look at another problem that we've done in the past that can result in a quadratic equation to solve it. So take a second, read through this problem. Notice that the three variables going on in this problem, we have a distance, we have a speed or a rate, and we also have a time. So we're going to set up our little chart like we did a couple weeks ago, distance, rate, time, for the two pieces of the trip, the local roads and the highway. Pause the video and see if you can plug in numbers into our chart. Let's check to see how you did. We've got 15 miles on local roads, 90 miles on the highway. On the highway, he traveled 30 miles per hour faster than on local roads. So if I say he traveled some amount of speed on the local roads, on the highway, he's going to be 30 miles per hour faster than that, or x plus 30. Now you might be thinking, oh, they didn't give us anything about the time other than the total trip was 2 hours. Well, remember, distance, rate, and time are related by the equation d equals rt. So I can solve this equation for t by dividing both sides by r. Then I can write myself an expression for the times for each part of the trip in terms of distance divided by rate. So for the local roads, his distance was 15, his rate was x. His highway, distance 90, divided by a rate of x plus 30. So our equation that we're going to set up now is that his time on the local roads plus his time on the highway should equal the total time for the trip. Now notice on the left of my equation, I've got two fractions being added, so I'm going to need a common denominator, which will be x and x plus 30. So my first fraction I'm going to have to multiply by x plus 30, top and bottom. And second fraction I'm going to have to multiply by x, top and bottom. So in my numerator, I'm going to have 15 times x plus 30, which will be 15x plus 450 plus 90x, all over x times x plus 30, which will really be x squared plus 30x. And there's where you're seeing we're going to get our quadratic equation from. And that's all equal to 2. Now, let's make this into a proportion so that we can cross multiply. I'll go this way first, which will turn into 2x squared plus 60x. And that's going to equal what we get multiplying the other way, which is easy enough. That's 15x plus 90x, which is 105x, and then plus 450. Now to solve this quadratic equation, I'm going to need this equal to 0. So let's subtract 105x and subtract 450. Now over here on the left, when I subtract, I've got 60x minus 105x, which I can combine into negative 45x. And there's nothing to combine with the negative 450, so that's just going to sit there. And now we've got our choice. Do we want to do unfoil Mr. Squiggly? Do we want to do complete the square? Do we want to do quadratic formula? I think I'm leaning quadratic formula on this just because if I divide everything by 2, that's going to give us fractions. I don't know off the top of my head what this would be to factor it out. So let's just do quadratic formula. X equals negative b, which would be positive 45, plus or minus radical b squared, which would be 45 squared, minus 4 times 2 times negative 450 all over 2a, which would be 2 times 2. Continuing to simplify this, the part underneath the radical turns out to be 5,625, and that's still all over 4. The square root of 5625 is 75. So let's get our two zeros by doing 45 plus 75 and dividing that by 4. We get x equals 30. Or doing 45 minus 75 divided by 4 equals negative 7.5. Now keep in mind the x at the very beginning of our problem was a speed. So does it make sense that we have a negative speed, a negative 7.5 miles per hour? Absolutely not. So this negative 7.5 is an extraneous solution that we are going to throw out. And so, going back up to our problem, we know x is 30, so his speed on the local roads was 30 miles per hour, and his highway speed is going to be 30 plus 30, or 60 miles per hour.